Okay, the first thing we're going to start with is what's the meaning of redox? Now, right. Redox is generated from two words, meaning read, then ox. Now, what does the word read means? The word read means reduction. Then the ox means oxidation. Now, before we start, the meaning of redox reaction. Like I said the word read means red, meaning reduction, then ox, meaning oxidation. That's one aspect. Now let's come to reaction. In chemistry, anytime we talk about reaction, it's simply when we have A plus B. Now when I say A plus B, I'm referring to reactant. Then C plus what? D. I'm referring to what? Product. So a reaction, or we say a chemical reaction, is when two or more reactants comes together, isn't it, to form a product. That's so A and B are acting as reactants, while C and D they are acting as products. So we have different kind of chemical reaction, up to like 7. We have addition reaction, combustion reaction, displacement reaction, thermal decomposition reaction, catalytic reaction, and we also have what? Redox reaction. Now the question is, redox reaction is more different than other kind of reaction. I'll tell you why. Pay attention. Now, if you look at this reaction now, for instance, let's give an example of H2 plus Cl2. I mean now, it will give us what? HCl. Are you with me? So I'm combining hydrogen gas with what? Chlorine gas to form what? Hydrochloric acid. In this case, hydrogen and chlorine they are disappearing to form what? A product. So whenever we are talking about any kind of reaction, like addition reaction, combustion reaction, the reactant disappear, then the product what? Appear. But when it comes to the case of redox, it's not that way. In redox, are you with me? Let us have A plus B, then C plus D. In redox, a reactant can turn to what? Product. And meanwhile, a product can be coming back to become a reactant. Are you seeing it? Reactant turns to product, then that product come back to become what? So that means reactant and product are occurring simultaneously. So let's define what is redox reaction, right? Redox reaction can be defined as a complementary reaction. Redox reaction can be defined as a complementary reaction. Redox reaction can be defined as a complementary reaction in which reactant turns to product and product to reactant simultaneously. Redox reaction can be defined as a complementary reaction in which reactant turns to product and product to reactant simultaneously. That's what we call redox reaction. Now in that case, we have there's what we call methods of redox reaction. There are up to 5. The first one, addition of oxygen. Second one, removal of hydrogen. Third one, oxidation number. The fourth one is loss of electron. The fifth one, displacement of more or less electropositive element. So we are going to begin this one after the other. Taking the first one, addition of oxygen. Now let's assume I have C calcium plus oxygen, which is in O2. Then they gave me CO. Balancing the equation, here should be 2, here should be 2. Are you with me? Now look at something carefully. Like I said, in redox reaction, we are having reactant converting to what? Product, then product back to what? Reactant. So in this case, calcium to calcium oxide, then calcium oxide to oxygen. Now looking at this case, from year to year, is oxygen added to calcium? Calm down, look at it. Look at calcium at the left hand side of the equation. Calcium is alone, isn't it? But when we come to the right hand side of the equation, calcium is married. Yes. So that means oxygen was added to calcium. So anytime you have addition of oxygen, it's called oxidation. Are you seeing that? But if you look at this case, hello, don't forget, if I have oxidation for one part of the reaction, what will I have for reduction? The opposite side of the what? Reaction. In that case, if my calcium oxide is turning back to what? Oxygen. What have I done? I remove oxygen, isn't it? So you have the what? Reduction. Is that clear? Yes, sir. And another thing you should note of is that there's what we call reducing agent and oxidizing agent. Reducing agent and oxidizing agent. Now, reducing agent, firstly, you can only find them in reactant. You can only see them at reactant. You cannot see them at the products because they will ask you, I don't know if they will ask you, that you identify the reducing agent of the chemical reaction. I don't know if they will ask. So in case they ask you to find the reducing agent between this and this, you can't find reducing agent at the products. You can only see reducing agent between what? The reactant. Now pay attention. The reactant that is oxidizing or undergoing oxidation is called reducing agent. The reactant that is undergoing reduction is called oxidizing agent. So look at this case. Calcium, is it undergoing oxidation or reduction? Calcium here is undergoing oxidation. So in that case, what will I call it? It's a reducing agent. What of what? Oxygen. Reduction or oxidation. So what will I call it? Oxidizing agent. So that's it. As simple as that. So should we go on? The next one is removal of hydrogen. One of your questions, hello, one of your questions asked this. Yes, it said divine reduction based on the derivation of what? Oxidation number. It was there in question 1. Should we go on? So the next one is removal. Okay, this one. Reducing agents and oxidizing, right? Reducing agents are atoms that become oxidized during reduction reaction. Oxidizing agents are atoms that become reduced, rather. Oxidizing agents are agents or atoms, rather. Oxidizing agents are atoms that become reduced during reduction reaction. So that's it. So let's go to the next one. B. Removal of hydrogen. A case that we can study is this. N2 plus H2 will produce what? NH3. Let's balance this. Two hydrogen atoms, two nitrogen atoms, we add 2 to this, we add 3 to this. There is a balance. So from year to year, then from year to year, N2 was, hello, look at this. Let's do it this way. This to this, then this to this. Now looking at this, nitrogen and hydrogen, isn't it? Now nitrogen was alone here, isn't it? And immediately nitrogen was what? Together with hydrogen. And they said removal of hydrogen is known as oxidation. So if nitrogen was added, it means here should be what? Reduction. Are you with me? But we look at this case, nitrogen and what? Hydrogen are together. So when it comes to this case, hydrogen was removed. So in that case, here is what? Oxidation. Now we can call this our what? What kind of agent is this? Oxidizing agent. What kind of agent is this? Reducing agent. The next one is oxidation number. Be fast, no time. Now, what's oxidation number? Right? You have a question? Yeah. Now, look at this case. Nitrogen and hydrogen. We see that nitrogen was alone at this side. Then when we come to the product, nitrogen was added to hydrogen. So in this case, the law says that removal of hydrogen is oxidation. So on the norms, if I should add hydrogen, that's not oxidation again. Because they say removal of hydrogen is what? Oxidation. So if I should add hydrogen, I'm reducing. That's reduction. But when it comes to this case, coming back to here, we see that our hydrogen was together with nitrogen. Now coming back to the reactant, it was split. So that means hydrogen has been removed. So that case at which hydrogen has been removed is now called oxidation. So when it comes to the reactant, the place that undergoes or that reduction takes place is called what? Oxidizing agent. While the place that oxidation takes place is called what? Reducing agent. So let's go. What's oxidation, right? Oxidation number can be defined as a charge or valency on an atom. Oxidation number can be defined as a charge or valency on an atom. That's the meaning of oxidation number, the charge or valency of an atom. So for instance, now, when I ask you guys, let's assume I ask you, tell me the valency. Let's talk about valency. What's the valency of hydrogen? +1, Abi? What's the valency of helium? 0. Valency of lithium? +1. Valency of beryllium? +2. Valency of boron? +3. Now, how do we know? Look at it. Let's assume I have oxygen, for instance. Oxygen is number 8. So if I should arrange it based on the shell, the K shell, the M shell, the K LML, is 2, 6, Abi? So how many left for it to become 8? 2. So that's why we say oxygen is now what? -2 by the valence. Let's talk about sodium, for instance. For the case of sodium, Na, that's 11. That's 2, 8, 1. So it's going to give out the 1. That's why sodium is what? +1.